Yes, 600 MCM THHN wire is suitable for use in a cable tray. THHN stands for thermoplastic high heat resistant nylon. It is a type of insulation commonly used for electrical wires in various applications. The suitability of THHN for cable trays depends on several factors, primarily related to the National Electrical Code, or NEC, and the specific installation environment. Cable trays are mechanical support systems that provide a safe and organized way to route electrical cables and wiring. Firstly, it is important to understand the properties of THHN insulation. THHN is known for its heat resistance, moisture resistance, and abrasion resistance. It is typically rated for 90 degrees Celsius in dry locations and 75 degrees Celsius in wet locations. This temperature rating is a crucial factor in determining its suitability for cable tray applications. Secondly, the NEC provides guidelines for the installation of cables in cable trays. Article 392 of the NEC covers cable trays. This article specifies the types of cables that are permitted to be installed in cable trays, as well as the installation requirements. Generally, THHN conductors are permitted in cable trays provided they are installed in accordance with the NEC. Thirdly, the NEC specifies the allowable ampacity, or current carrying capacity, of conductors. The ampacity of a 600 MCM THHN conductor depends on its temperature rating and the ambient temperature. NEC Table 310.15b16 provides ampacity ratings for conductors based on their insulation type and temperature rating. For example, a 600 MCM THHN conductor rated for 90 degrees Celsius may have a higher ampacity than the same conductor rated for 75 degrees Celsius. Fourthly, when installing THHN conductors in cable trays, it is important to consider the dirting factors specified in the NEC. Dirting factors are used to reduce the allowable ampacity of conductors when they are installed in close proximity to each other or in environments with high ambient temperatures. NEC Section 310.15b3 addresses adjustment factors for ambient temperature, and NEC Section 310.15b3 addresses adjustment factors for the number of current carrying conductors in a raceway or cable. These dirting factors must be applied to ensure that the conductors do not overheat and cause a fire hazard. Fifthly, the type of cable tray being used can also affect the suitability of THHN conductors. Cable trays are available in various materials and designs, including ladder trays, ventilated trough trays, and solid bottom trays. The type of cable tray selected should be appropriate for the application and the type of cables being installed. For example, a ventilated cable tray may be preferred for applications where heat dissipation is a concern. Sixthly, proper support and securing of the THHN conductors within the cable tray are essential to prevent damage and ensure long-term reliability. The NEC specifies the spacing requirements for cable supports. These requirements vary depending on the size and type of cable. The conductors should be properly secured to the cable tray to prevent them from sagging or rubbing against the tray. Seventhly, when installing THHN conductors in cable trays, it is important to consider the environment in which the cable tray is located. If the cable tray is located in a wet or corrosive environment, it may be necessary to use special types of cable trays and fittings that are designed to withstand these conditions. THHN insulation is moisture resistant, but it is not waterproof. If the cable tray is exposed to direct sunlight, it may be necessary to use sunlight-resistant THHN conductors. Eighthly, proper grounding and bonding of the cable tray system are essential for safety. The NEC specifies the requirements for grounding and bonding cable trays. The cable tray should be properly grounded to provide a path for fault current to return to the source. Bonding jumpers should be used to connect all metal parts of the cable tray system to ensure electrical continuity. Ninthly, it is important to follow all applicable local codes and regulations when installing THHN conductors in cable trays. Local codes may have additional requirements that are not specified in the NEC. It is the responsibility to ensure that the installation complies with all applicable codes and regulations. Tenthly, consider the specific application for which the 600 MCM THHN conductor is being used. For example, If the conductor is being used to supply power to a motor, it is important to consider the motor's starting current and the voltage drop in the conductor. The conductor should be sized appropriately to handle the motor's starting current and minimize voltage drop. 11thly, regular inspection and maintenance of the cable tray system are essential to ensure its continued reliability. The cable tray should be inspected periodically for any signs of damage such as corrosion, cracks, or loose connections. Any damaged component should be repaired or replaced promptly. In summary, 600 MCM THHN conductors are generally suitable for use in cable trays, provided they are installed in accordance with the NEC and all applicable local codes and regulations. It is important to consider the temperature rating of the conductor, the ampacity of the conductor, the directing factors, the type of cable tray being used, the environment in which the cable tray is located, and the specific application for which the conductor is being used. Proper installation, grounding, and maintenance are essential to ensure the safety and reliability of the cable tray system. Always consult with a qualified electrical engineer or electrician to ensure that the installation meets all applicable requirements. The suitability of THHN wire in a cable tray is also dependent on the specific manufacturer's specifications and listings. Always refer to the manufacturer's data sheets for detailed information about the wire's properties and applications. The 600 MCM size refers to the cross-sectional area of the conductor, measured in circular mils. MCM stands for 1000 circular mils. The larger the MCM size, the greater the ampacity of the conductor. Therefore, a 600 MCM conductor is capable of carrying a significant amount of current. The NEC tables provide specific ampacity values for different conductor sizes and insulation types. It's important to note that the NEC is updated periodically, so it's always a good idea to refer to the latest version of the code. Understanding the NEC and local codes is essential for anyone involved in electrical work. This includes electrical engineers, electricians, and building inspectors. Compliance with these codes is crucial for ensuring the safety of electrical systems. When selecting THHN wire for a specific application, it's important to consider the voltage rating of the wire. THHN wire is typically rated for 600 volts. This means that it is suitable for use in systems with voltages up to 600 volts. For higher voltage applications, other types of wire with higher voltage ratings may be required. The insulation on THHN wire is made of thermoplastic material. This material is resistant to heat, moisture, and abrasion. It also provides electrical insulation to prevent short circuits. The nylon jacket on THHN wire provides additional protection against abrasion and chemicals. This makes THHN wire suitable for use in harsh environments. The color of the insulation on THHN wire is typically black, white, red, blue, or green. The color coding is used to identify the different conductors in a circuit. For example, the black wire is typically used for the ungrounded or hot conductor, the white wire is typically used for the grounded or neutral conductor, and the green wire is typically used for the grounding conductor. Proper color coding is essential for safe and reliable electrical wiring. When installing THHN wire in a cable tray, it's important to use the correct type of connectors and fittings. The connectors should be compatible with the size and type of wire being used. They should also be rated for the environment in which they are being installed. Proper connections are essential for preventing loose connections and short circuits. In addition to THHN wire, there are other types of wire that are commonly used in cable trays. These include XHHW wire, use wire, and MC cable. Each type of wire has its own unique properties and applications. XHHW wire is a type of cross-linked polyethylene insulated wire. It is similar to THHN wire, but it has a higher temperature rating. Use wire is a type of underground service entrance cable. It is designed for direct burial in the ground. MC cable is a type of metal-clad cable. It consists of insulated conductors enclosed in a metallic sheath. The type of wire selected for a specific application depends on the specific requirements of the application. When working with electrical wiring, it's important to always follow safe work practices. This includes wearing appropriate personal protective equipment, such as safety glasses and gloves. It also includes de-energizing circuits before working on them. Never work on live electrical circuits. Electrical work can be dangerous, so it's important to be properly trained and qualified. If you're not comfortable working with electrical wiring, it's best to hire a qualified electrician. A qualified electrician has the knowledge, skills, and experience to perform electrical work safely and correctly. They can also ensure that the electrical system complies with all applicable codes and regulations. In summary, the suitability of 600 MCM THHN wire for use in a cable tray depends on several factors, including the NEC local codes, the manufacturer's specifications, and the specific application. It's important to consider all of these factors before making a decision. Proper installation, grounding, and maintenance are essential for ensuring the safety and reliability of the electrical system. Always consult with a qualified electrical engineer or electrician if you have any questions or concerns. Remember to always prioritize safety when working with electricity. Electricity can be dangerous, but it can also be used safely if you follow the proper precautions. Be sure to educate yourself about electrical safety and follow safe work practices. By doing so, you can help prevent electrical accidents and injuries. Consider, too, the full capacity of the cable tray. The NEC specifies the maximum number of conductors that can be installed in a cable tray. This is to ensure that the conductors are not overcrowded and that there is adequate ventilation. The full capacity of a cable tray depends on the size and type of cable tray, as well as the size and type of conductors being installed. Also be aware of any restrictions on the use of THHN wire in specific locations. For example, some jurisdictions may not allow THHN wire to be used in direct sunlight. In such cases, it may be necessary to use sunlight-resistant THHN wire or to provide additional protection from the sun. The importance of proper documentation of the electrical system cannot be overstated. This includes keeping accurate records of all wiring diagrams, equipment specifications, and inspection reports. Proper documentation can be helpful for troubleshooting problems and for making future modifications to the electrical system. Maintaining a safe and reliable electrical system requires ongoing effort and attention to detail. By following the guidelines and recommendations outlined above, you can help ensure that your electrical system operates safely and efficiently for many years to come. The information provided is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrical engineer or electrician before making any decisions about electrical wiring or equipment. They can provide you with specific recommendations based on your particular needs and circumstances. Finally, remember that electrical codes and regulations are constantly evolving. It's important to stay up to date on the latest changes to ensure that your electrical system complies with all applicable requirements. You can stay informed about code changes by attending industry conferences, subscribing to trade publications, and consulting with electrical code experts. By staying informed and following safe work practices, you can help ensure that your electrical system is safe, reliable, and compliant with all applicable codes and regulations.